Hello and welcome to our introduction video on ConSTR, a contextual search term recommender. So ConSTR is basically a two-layered search term recommender, where the first layer provides recommendations related to the current query of a user, and the second layer provides recommendations related to the user's previous search behavior, known as the interaction context. In this video, I will show these recommendations in detail, but first let's have a look at the demo application. We have here a very simple demo application which consists of many features that we can find in many modern digital libraries today. So first of all, we can see here that we indexed 1.9 billion documents. We extracted these documents from a freely available archive dump, which consisting of 1.9 million documents, which we then indexed in an Elasticsearch index. On the left side, we can see features such as selecting the page size, so the number of documents per SERP, and we can see facets on the basis of keywords, authors, and categories. Here is the search result page, and here we can see model settings and the interaction context, which I will introduce later on in the video. So let's assume a user starts his or her search with a query term, bibliometrics, and h-index. You can hit enter to submit the query. And we can see here that we get search terms, documents related to the user's query. On the right side, we can already notice that the current query of a user has been added to the user's interaction context. So the interaction context is basically a simple representation of previous search behavior, which stores two elements: all queries the user has submitted so far, and all keywords present in a document a user has clicked on. So let's look at the behavior with respect to keywords. So we have here a search result page, and we scroll a little bit down, and we can see here a document, for instance, PageRank for ranking authors in co-citation networks. You can click on the document, and we can see here a detailed view of that particular document consisting of different metadata, such as the title, when the document was published, the authors, categories, so in this case archive categories, here computer science and digital libraries, and an abstract of that particular document. So one feature of our demo is that we extracted keywords for each archive document using Yake, which is an unsupervised automatic keyword extraction method. You can see the extracted keywords here: web pages, PageRank, information retrieval, web, and co-citation. So usually documents in the archive do not contain keywords. However, keywords are extremely helpful to classify and label the topic of a particular document, and hence we decided to enrich our dataset using the mentioned keyword extraction method above. For extraction, we used the abstract of each document. So let's close the detail view and scroll back to the top of the page. And we can see here that the keywords of the document a user has inspected in detail have been added to the user's interaction context. So here, and we can see here the terms from the document. Of course, we've used an automatic keyword extraction method, and therefore we might have some very generic keywords, for instance, web pages, or information retrieval. And one of the ideas of ConSTR is to provide a transparent interaction context, to allow a user to understand the source of the recommendation and also to adjust his or her interaction context. Therefore, a user can now interact with this interaction context and, for instance, remove unnecessary terms like web, information retrieval, or web pages. I mentioned earlier in the video that we are using two sources to recommend search terms. One is the current search query of the user, so bibliometrics and h-index, and the second source is the interaction context. And now let's look at search term recommendations for our current situation. We can see here our two-layered design. On top we see recommendations which are related to the current user's query, so bibliometrics and h-index. And we can see here that we can recommend the following two terms, so scientometrics and infometrics. In the second layer, we see recommendations which are related to the user's interaction context. And we can see here, for instance, the term networks, which is of course very related to PageRank. So a user can now, for instance, click on a recommended term, and this term is then added to the current search query. So this query is now enriched with networks, and we can immediately see that the term is now not only bibliometrics and h-index, but we're also looking for networks, like for instance here, bibliometrics for internet media. applying the age index to YouTube. We are also able to adjust our model. This is done here with model settings. We can adjust the similarity threshold, we can adjust the number of recommendations that are provided, and we can change the embedding model. So we can switch between two embedding models. One is an embedding model which we developed from our 1.9 million archive documents, and the second embedding model is the Wikigiga 5 model, which is pre-computed. So one of these models is of course very specific, which is the archive model, and the other one is maybe more generic, the Wikigiga 5 model. So these are the basic features of our ConSTR application, and of course we are at a very early stage of our demo application. We are constantly adding new features, and we will also try to constantly update this channel. So ConSTR is currently in a demo phase, and features are improvements are constantly added. You can either find new information on the ConSTR website or in this YouTube channel. Thank you.